Swayam Prabha. Digital India. Educated India.
Welcome back, dear learners, to this NPTEL course on low cost building materials and techniques. My name is Dr. Vishal Chettry and I am working as an assistant professor in the Department of Architecture, Planning and Design at IIT BHU Varanasi. In this lecture today, we will focus on understanding about earth as a building material, wherein we will understand its global applications and typologies. So, from this unit over, we will focus gradually on specific materials and understand how they would help anyone to build a low cost building or to promote low cost architecture. So, with this, let us now focus on understanding first about earth as a building material, because it is locally available and it is one of the one of the earliest material that humans have started building with. So, with this let us now look into the details of this particular presentation. So, the content of this presentation will include details about the earth as a building material. We will understand how the use of earth as a building material started and some background to this particular overall topic, and then we will understand about the material characteristics and the properties of earth, because this is also one has to understand, as I had explained earlier. As an architect or as an engineer, when you work with different materials, and then when you apply in certain different for different uses or purpose, you have to understand the characteristics and the properties of that material, because after that you will be able to give a well thought recommendation or well thought decision to in any circumstance. So, that is why understanding the characteristics and properties are very important, especially in building industry, because you have to understand how does it behave in different circumstances. Like if a region is has lot of like if it is predominantly a hot and dry climatic region. So, over there you have to understand how the material that you are suggesting to be used for the building will behave. Will it enhance the comfort of the user, or will it create further issues in the during the use of that particular space. So, these things only can be decided or only can be suggested if we have an understanding about the characteristics and the properties of the material that we are suggesting for the use. So, that is why we will be understanding about these same aspects of earth here in this particular unit. Then we will also understand about the various components of earth and understand and also it will help you in deciding on doing a testing or understanding the components, and if it requires any further additional material in terms of components. So, it has should it be added or is it fine to start with. So, these things are necessary for the more understanding about the topic. Then we will also figure out what is the usability of earth components. So, there are different components of earth, because when we see any part of earth that is lying around us. So, if you take out a handful of earth in your hand, there are certain components in it. So, we will understand what are those components and also understand the usability of these components of earth. Then we will understand different traditional earth construction techniques that have been in use since ancient ages. Also, we will understand the global typologies of earth architecture, then some contemporary innovations that has happened in earth construction. Then we will focus on sustainability and environment performance of building which uses earth as a building material. And then we will conclude the lecture along with some wrap up activities, some glimpse of topics that will be covered in the next presentation. Along with that, I will share you a list of resources so that you can refer them in your more understanding about this topic. Now, but before progressing further on the topics that I have just shared that we will discuss in the presentation, let us also recap what we have learnt in the previous presentation. So, we have understood the vernacular architecture as a climate responsive and locally evolved building practice. We understood the relation between a vernacular architecture and that with the climate responsive building, and also with the low cost building material and design. So, how are these things interrelated, and we try to understand these concept, and also like it helped in creating some sort of awareness that low cost architecture need not be always something which is low cost, but it does not add comfort to the user. It is contrary to that most of the material that we use which are of low cost has an added advantage in terms of creating a climate responsive building, as well as designing a sustainable building, and also it promotes in low cost in coming up with a low cost project. Also, we understood how traditional buildings, that is the vernacular architecture, handles heat, humidity and rainfall through ventilation, shading and moisture control. So, in different climatic in different scenarios, if the climatic zone in a region is hot and dry, so what sort of your building element, the design of the building should be, so that it controls the heat that is allowed to enter, and how it creates some cool microclimate inside that building. So, what are these materials, or what are the techniques? So, we try to understand that. Then also we understood about Jaisalmer Havelis from because of the compact planning that is involved in its design, the use of sandstone, use of courtyard, as well as jali, how it is helping in passive cooling of building, and then we are less dependent on active means of cooling a space. We also examined Chandni Chowk Havelis for shaded streets, courtyard design, and also thermal comfort in composite climate. We also analyzed Kerala's vernacular architectural style, that is Nalukettu houses for timber construction, sloping roofs and ventilation in humid conditions. So, in Kerala especially, where you have mostly warm and humid climate conditions, so you have to allow more of cross ventilation inside the through the building. So, that is how how it is actually done is through by learning the vernacular architecture of that region, and these techniques have very well been explained in the previous lecture. So, if you have any doubt, or if you are not able to recall these points, so just please go back to the previous presentation and understand these details about vernacular architecture and its relation with climate responsive building, also with the low cost architecture. So, now till previous presentation we have covered enough of background about low cost architecture and what are different ways by which low cost architecture is possible. But to focus on understanding about the use of different materials in designing a low cost building, it should start from this particular lecture onwards. So, let us now look into understanding earth as a building material. Earth is one of the oldest construction material which has been used for over 10,000 years in human settlement. So, it is not something which we have started using in recent time, but contrary, it is one of the oldest material that has been used for especially in designing or construction of any building. So, nearly around 30 to 40% of world's population still lives in earthen structures. So, this is what the statistics suggest, that still today at least 30 to 40% of the entire population in the world lives in earthen structures, and that actually creates a question in mind, that why still people are living in earthen houses. So, what is the advantage are they getting because of living in such houses, or is it due to compulsion that they do not have any option? So, you have to figure out this and post it in the discussion section. Also, the other important aspect of earth as a building material is that it is locally available. It is a material that is available in different kind of climatic zones. So, it is not only that we find earth to be used in warm and humid region, but it is also available in cold and cloudy, cold and sunny, moderate, composite, hot and dry climatic region, except the desert area where it is mostly sand and sand dunes that are available. But in some other areas that still are in hot and dry climatic region like Jaipur and other places, so there you still have the availability of earth as a local material for construction of buildings. Then also it is a low cost material because it is abundant in the earth and it is readily available. You do not have to do mining, or you do not have to process it for its use for the construction. So, that is the major advantage why earth has been in use since past many centuries. In fact, that earth has been used as for building construction. So, the earliest civilizations that we have seen in Asia, like Harappan civilization, Indus Valley civilization, and likewise the other civilizations that were present in earth has exhibited that the material like earth has been used for construction in many of these civilizations. So, you can visualize the use of earth for construction since when it started until today. You will find its use in mostly, as mentioned here, 30 to 40% people still utilize earth as a building material. There may be some compulsion that because of they are not able to construct a building out of RCC because of heavy cost, like that is the material cost that goes behind in RCC buildings. But because of not only this issue, there are many other group of people, despite earning sufficient, they still prefer to live in such earth constructed building because of the conscious decision that using earth they are actually promoting sustainability as well as minimizing the dependency on active means of cooling or heating of spaces. Then the other aspect is that it requires minimal processing. So, like as I was explaining you, when you have to use a particular stone for construction, so there it is not like you just get a huge boulder and that you have to use it for construction. You have to process it, you have to make it in definite shape or size, and then it will be usable for the construction. So, compared to other low cost material, earth is one of the rare material which requires minimal processing. But other materials, like if it is bamboo also, still it has to be cut, it has to be it has to be bent, or some tying has to be done, so that only then it can be used for construction. You cannot just go to forest and then just bring out pieces of bamboo and then use it for construction directly. Some pre-processing has to be done. Also, you to make it the construction, to make it more durable, you may have to apply some preservative or some treatment has to be done so that the structure is durable. So, these are the added added efforts that has to be applied in other materials. Compared to that, if we see the use of earth as a material, there is no such no such effort that has to be applied. Just the earth that is available, but the thing is you have to do a testing, you have to ensure the components are there, required component, and then you have to use it for construction. If it is adobe block, then some effort like putting it into some formwork, and then you get a block, you have to dry it. If it is a cob wall, there is a different process. If it is a rammed earth wall, it is a different process. So these are different process that goes behind in different types of structure, but overall the effort is minimal compared to other low cost material. Also in terms of transportation, since it is readily available in a site, so you have to go for a foundation, so you have to do some digging of earth. So the same earth that you have taken out from the site can be used for the construction purpose. So that is also the reason why the transportation cost is minimized in this case. Then the traditional earthen architecture also reflects climate responsiveness, cultural identity and resource efficiency. So in many of these regions, like when you visit the hot and dry regions of India, like the western part of Gujarat or western Rajasthan, you will find many houses which are made up of mud completely or earth completely, because of the cultural significance. So that entire region is now known for the earthen architecture that they have developed. Also it has become a cultural identity of that place. Also it ensures that there is resource efficiency that is happening, and also it promotes some climate responsive architecture of for the users. The common forms of using earth as a material includes mud houses, earthen plasters or load bearing walls. In India, regions like Rajasthan, Ladakh and Kutch extensively use earth due to climatic suitability, because it has inherent property which attempts to make the microclimate very comfortable for the user. So that is the reason why earth has been preferred for use in many of these regions, because these are very harsh regions, either it is very cold or it is very hot. So in both the circumstance, earth is a preferred choice for construction of buildings. Understanding why earth has survived for millennia requires examining its material properties and performance. So that is why we have to understand the property and the significance of these material. So now let us understand the characteristics of the earth that is used for construction. So if you see this particular image here, this is how a part of earth, if you see the section, would generally look like. So there is a top layer which is an organic material, and this is what is the fertile layer of the earth, and it contains some decomposed plant and animal material, and also some mineral component in it, and then it is a very good source for the plants to grow. So that is why the top layer, that is the organic layer that is present, or organic matter in fact that is present, has to be avoided for use. So you have to avoid using this particular top layer, and if in a site you are doing excavation, then probably that part of earth at least 15 to 20 centimeter has to be kept separately, so that when you go for landscaping or or for gardening in and around your site, so you can use this same top layer and use it for other purposes, for plantation, for landscaping, and similarly for other purpose, but it cannot be used for construction because of the organic matter that is present in the top layer. Then the active soil that is present just below that top layer is a suitable material that has to be used. Then what it contains is these these components. So these are the major components of earth as a building material. So it includes stones, gravel, sand, silt and clay. So all these together is actually what the earth is all about. So earth includes these component, and based on that, based on the percentage of these constituent, we can determine the quality of earth for construction. Then if some of the component, like as you see here, soil behavior properties, so compatibility. So soil fits well with other materials without adverse reaction. So this is also the advantage, that it is a very compatible material and it doesn't react very very strongly with any other material when it is mixed. The other property is cohesiveness, that particles stick together providing internal strength. So due to the percentage of clay in it, it helps in binding with the surface very easily. The next property is about plasticity. Soil can be molded or deformed without cracking, provided it has certain constituent material within it. So if it is desired constituent of clay, silt, sand, then you can mold and prepare any shape of building that you want. So it doesn't crack, it will not crack in that way. The other material characteristics that you have to understand is about the soil layer, that is the organic layer and construction layer, that is the top 60 centimeter that we use, that we generally see that is available in the earth, has to be avoided for use. It should be used for farming and not for construction. So at least 60 centimeter, but in some regions it is just the top layer which is limited to 15 to 20 centimeter, but at the max it has been seen that till 60 centimeter of earth it is mostly the organic layer. The next is about soil composition. So it is the inert components such as stone, gravel, sand and silt. It provides strength and stability, while the clay binder that is present, it is the fine clay particles which binds the soil together. So these inert component like stone, gravel, sand and silt, so they are all binded with each other because of the clay content in the soil. The next is about the mechanical properties like compatibility. Soil particles compact well, they create dense and strong walls. Regarding the cohesiveness, soil holds together under pressure, so it maintains the shape and durability of the structure. Regarding plasticity, soil can be molded easily because of the constituent clay that is present in the earth, and then it is useful for bricks and also for the curved form of the structure. So that is why the circular form of building or any other innovative form that you desire for the structure is very much possible using earth as a material. Then these are some of the other characteristics of the earth. So it is a building material which derives its performance from its natural composition and physical behavior. Understanding its characteristics is essential to evaluate its suitability for structural stability, thermal comfort and durability. That is what I was mentioning earlier also, that any material, it is not only about earth. When we use any material for construction or for any other purpose, we have to understand its behavior, its characteristics, so that we can determine the structural stability, where either it will promote thermal comfort or will it create some obstruction in thermal comfort. So that can be only understood if we understand the characteristics of the material and also the durability in different climatic contexts. So if there is heavy rain, will the material corrode, or will it get out or will get off from the wall or from the place where it is kept. So these are the things that has to be determined by understanding the characteristics of the material. So earth is a composite material. So compressive strength typically ranges from 1 to 5 MPa. It can reach 10 MPa when it is stabilized, that is megapascal. High thermal mass helps in regulating indoor temperature by absorbing and releasing heat slowly. The thermal conductivity also makes it suitable for passive cooling of the building. It is an excellent hygroscopic material because of the moisture regulation that is the inherent property of the earth, and also the indoor humidity which it maintains for around 40 to 60%. The low tensile strength, so that is why it is not suitable for thin construction or for constructing kind of column or beam kind of structural component. So that is why when we use completely earth as a material without any other mixing of other material, the walls that we create has to be thicker so that it is able to take up the load of the structure. So usually 300 to 600 mm of of thickness is desired. It is vulnerable to water erosion because of the inherent property of the earth, because it just contains sand, silt and clay, and then clay, it reacts very fast with water. When it comes in contact with water, because of the material properties, it starts to like come out of that particular place along with the water, because of fine texture and the inherent property of the material itself. So these properties directly influence how different traditional construction techniques have evolved over the years. So if we see the component of soil, it includes gravel. So it is a very bigger in size, the material is like that. Then the stones of a size of a pea to an egg is known as gravel, doesn't disintegrate after soaking in water for around 24 hours. So this is some technical definition about what a gravel is all about. Then next is the sand. So it is small pieces of stone. So due to weathering, due to weathering of stones, you will find it converted into small pieces. That is what is sand, and it is smaller than pea but similar to gravel. Then each grain is visible to eye. So that is sand, the technical definition for sand. Then next is silt. It is same as sand but more fine than the sand. So it doesn't disintegrate after soaking in water for 24 hours. The next is clay. So soils that stick when wet and gets hard when dry. So that is clay, may or may not shrink when drying depending on the characteristics of the soil. So if it is a red soil or a clay soil, black cotton soil, and since you know the availability of different types of soil within the country, so based on the properties of this soil, the clay may shrink or it may not shrink if it has much higher clay content in it. So organic soil, it is mainly composed of organic matter not suitable for construction. So you have to avoid this top layer of soil. It is not like that when you cut a piece of earth and you will find it in this proportion. This image is just to explain the different components of soil and how it reduces as we as we come to the top layer of the earth as a material. Then mixtures, a mixture of any of the above soil like sandy clay, clayey sand, clayey gravel soil. So these are different types of soil that are available within a country or within a particular region. So if we have to understand the usability of earth components, so gravel alone is of no use for mud wall building. The tiny lumps of stone have nothing to bind them together. So if a place which has lot of gravels available, and since it is a part of earth, we can't say that we can use that same earth for construction, because alone it will not help in binding of material, or it will not withstand a particular shape that we want for the building. For example, we want a straight wall, but using gravel alone we can't get a straight wall for the building. So it requires sand, it requires silt, clay and the other components of earth. Next is sand. It is similar to gravel. It is of no use for wall making by itself, but if it is mixed with clay, it is the ideal mud wall building using soil. So you can do this experiment yourself. You can put pieces of gravel together and see if you are able to achieve a straight wall till at least 2.1 or 2.5 meter of height. Similarly, you can experiment this with sand. If it can withstand that vertically for at least 2.5 to 5 meter, then you can decide on that which would be the best material to work with. The next is silt. By itself it is also no good for building walls. It will hold together, but it will not be strong. Furthermore, it will not compact, so it is also of no use for pressed blocks or rammed earth walls. Clay, the clay earth can be rammed or compressed, but in drying out often they shrink. If the constituent of clay within the earth sample is very high, then these issues may occur. During the monsoon they get damp and expand again, which ultimately leads to crack, like development of crack in the surface. So these things has to be understood, that individually these materials may not be an ideal material to work with for low cost building or using earth construction, but if it is mixed well, if it is available in certain proportion, then it is an ideal material to construct building using earth as a material. So these are let us now see what are different traditional earth construction techniques that has been seen through the ages. So the first that we see is adobe blocks. So these are still there in many of the excavated sites of Indus Valley civilization and Harappan civilization. So we can still find sun dried earth bricks that has been used, which was made from clay, silt, sand and water. So these are materials that we often think that earth is it can disintegrate very easily and it is not a durable material, but you can compare that the material has been in use since ages and it is still there in its desired form. A definite block, you can find it still today in excavated sites. So these are very strong and very durable material. The next is rammed earth walls. It is a compact layer of moist earth placed in forms and then it is rammed using rammer. So rammer can be both mechanical and and also manually also you can do it, and then you get these different layers of soil as you see here in the image. We will study about all these types of earth construction technique in detail in upcoming lectures, but here this is just to give you a glimpse. The next is cob wall, a plastic earth mixture where we just when we ready the mixture, we will just put it using hand and then we will make a layer by layer construction of the wall. The next is wattle and daub. It is the wattle, that is a bamboo mat, and then daub, that is the mud layering that is done from both the external as well as internal surface. For example, if this is your bamboo mat that is there as a wall, so from both the surfaces, external as well as internal, we will apply this mud plaster from the from both the sides, and then what you get is a example of wattle and daub wall. It is very much common in northeast region. So if you have visited any village areas of villages of northeast India, you will find wattle and daub wall very common material that they use for construction. The next is tapia. So it is a type of construction where moist earth is mixed with small stone packed in lifts within forms, as you see here in this image. It is very much similar to Katkuni architecture, but over there at equal intervals you will find the use of timber as well as of the stone. So but here it is being replaced with mud as a material. The next is earth plaster, that finishing walls with a thin layer of earth plaster for protection and beauty. So this is actually done in many of the villages here in this Indo-Gangetic plains, because people can't afford that much of cement for construction. So what they do is, since burnt bricks are readily available, so they use it for construction, and then just to apply the plastering of the surfaces, then they go for mud as a material over there. So these techniques vary on soil composition, climate as well as on the cultural or traditional practices. These techniques result in diverse global architectural typologies that has been shaped by the climate. So as we see here the entire world map, and here the famous the areas where the earth architecture is predominant, you can see here mostly this region which is near the equatorial belt. So somewhere here I guess the equator may be passing from here, and then these are the two regions where you will find earth is predominantly used for. There are some regions here in small portions where you still find earth is used, but mostly it is limited to somewhere near the equatorial belt, the earth construction is used. So some of the very famous UNESCO World Heritage sites are in fact these earth construction buildings. So great mosque of Jin, Mohenjo-daro, the excavated remains, the Babylon, the remains of Babylon, as well as of Dholavira. So all these UNESCO World Heritage sites have used earth as a construction material. So in Africa, in this great mosque, they have used adobe or mud brick. In Mohenjo-daro and Harappa, it is mostly sun-dried or mud brick. In Babylon also, you find these common materials that has been used for construction. So the typologies that we have seen in construction is can be seen here, like in hot arid regions like North Africa, Rajasthan, there the walls are very thick. So these kind of houses are present, a circular house with thatch roof in rural Rajasthan and in Africa. So the walls are as thick as 500 to 800 mm for thermal insulations, and less windows are placed, as we have discussed earlier. The next is in hot humid regions, mostly in Southeast Asia, the plinth is raised and then the walls which are made of earth are more breathable. That is why it is preferred in humid regions. In cold climatic regions like Ladakh, the compact form of the building along with the use of mud is one of the best combination for designing a building in this region, because it promotes, or it actually reduces the heat loss from the building. Next is the clustered settlement that reduces solar exposure and creates shaded microclimate. So it is seen in Jaisalmer, where the buildings are designed very close to each other and then a narrow street, along a narrow street, so that the people who are walking in that street may not face direct sunlight during the day because of mutual shading of the building. Also it creates some kind of funnel effect by allowing air to pass through that narrow street. The air is actually it is channelized through that narrow part of the street, and then it brings fresh air in that region. Then other typology is it demonstrates strong relationship between climate material as well as the form and settlement pattern. While traditional typologies are efficient, modern needs have led to technological innovations also. So what are these technological innovations? Like compressed earth block that has been used in Nalanda University here in Rajgir. So you can, or in Nalanda you can just do a study of that, and you can find out how CEB is used and how it has added in increasing the sustainability of the project. The next is stabilized earth block. Then there are engineered rammed earth block. The also use of geopolymers and additives has been used. So these are different interventions and modern innovations that has happened in earth architecture, and now it has been very much popular in construction. As I was explaining you, earth architecture also promotes sustainability and environmental performance. So earth architecture, the material that we use has very low embodied energy, so that is the reason why it promotes sustainability. It reduces carbon emission because of less usage of concrete. It is fully recyclable and biodegradable unless it is burnt, like we see in burnt clay bricks. It contributes to circular construction. It provides passive thermal comfort, reducing energy consumption by about 20 to 30%. Use of local soil reduces transportation cost, and as well as the overall cost of the building. It improves indoor air quality and regulates humidity. By also in some cases it has been found that using earth, the pollutants that are present inside the house has also been reduced. It also supports sustainable rural development, and the local employment is generated because people have still skills related to this earth architecture. So these people can be used for construction, and then it will generate employment for them. In the context of growing environmental concern and climate change, earth architecture is one of the best solution for any building to be designed with. Earth stands out as a sustainable alternative, mostly due to the low embodied energy, minimal emissions, and compatibility with passive design strategies. So to conclude this lecture, we can understand, or we can overall summarize that earth is a time tested material. It has been used since ages, and still today it has its relevance for construction. Its thermal, environmental and economic advantage makes it highly relevant till today. Traditional techniques demonstrate that climate responsive and culturally embedded design is very much seen still today. Modern innovations have improved strength, durability and scalability of earth. Challenges also includes like water vulnerability, standardization, as well as social perception towards earth architecture. So with proper design, earth buildings can last more than 100 years, and since we have seen buildings which are still there today, which were made centuries ago, so that is a myth that earth architecture is not a durable construction. Future potential lies in the policy support, in how the research and innovation happens in using earth as a material in today's time. So these are some activities which you can complete after at the end of this lecture, as these has been covered in the lecture also. These are the topics that will be covered in the next presentation, which will be mostly about the properties and soil testing for mud construction. So these are resources which you can refer for more understanding on using earth as a building material. So with this I would like to conclude this particular presentation, and I hope that this information is very much helpful for you to understand or contextualize the use of earth for low cost architecture. So thank you for your patience listening.